Now, previously we added inline JavaScript into the attribute of our body. This time, what we want to do is go into the head section. I'm going to go right underneath the title. And I'm going to add a script tag and a closing script tag. And we'll add our JavaScript here for this example. All right? And to satisfy HTML5, what we're going to need to do is also add an attribute called type equals. And inside of the double quotes, I'm going to type in the type of data or information that the web browser should expect to see inside of the script tag. In this case, it'll be text / JavaScript, all lowercase, no spaces between the two. All right, and so it should expect to parse out anything that we type inside here as JavaScript. All right, and we'll talk about these concepts a little bit later in the next video. So I'm going to type my first JavaScript. I'm going to create a function, and again, we'll talk about what functions are later on. It's not really necessary that you understand what it is just now. Just make sure you follow along. So I've made some indentation here for myself. I'm going to type in function space, and I'm going to give this function a name. We're going to give it the name of substitute, and then followed immediately by an open close parentheses, and then I'm going to make a space and then add an opening curly brace, and then go down a couple of levels and then a closing curly brace. And in between here, we're going to write the body of our JavaScript function called substitute. Now, you can see here that I'm paying attention to indentation levels. For example, this curly brace is going to line up with the F, and this is more for my readability than it is for Internet Explorer as it parses through and tries to execute this. I just want to be able to read this cleanly, and so I am paying close attention to indentation levels as I'm typing my JavaScript in. All right, and I would encourage you to follow the same practice here at first. All right, so then the next thing I want to do is start to create the body of our substitute function. Again, we'll talk about what functions are and all that good stuff a little bit later. Just follow along. I'm going to create a variable called myValue. We'll talk about what variables are later. So var space myValue, capital V in value, equals, and then I'm going to try to get the value of whatever the user typed into the text box. So I got to type in this long incantation. We're going to call the documents get element by ID method or function, open and closing curly parentheses, dot value. All right, and inside of this get element by ID function, we need to tell it which element we want to get. And we're going to use the ID because we're using get element by ID. So which ID do we want to read or find the value of? My text box. So I'm going to hit Control-C on my keyboard to copy this. I'm going to use two single quotes inside of the get element by ID, and I'm going to paste my text box in between there. So now your code should look like that. Okay? Now the next thing I want to do as I indent my way into the function's body is check to make sure that somebody actually typed something into the text box. So I'm going to type if myValue.length is equal to 0, not the O or the capital O on the keyboard, but the number 0. All right, then, so make sure you have an opening and closing parentheses. Make sure you're using two equal sign. That's important. And this length, we'll talk about what it does later, but essentially how many characters are inside of this value that we retrieved from my text box. We're going to add an opening curly brace, go down a couple of lines, indent my way over, and use a closed curly brace and make sure that it lines up with the I and if, again for my own readability. And then I'm going to indent in about 2 more spaces and type in the word alert. We've already seen the alert in action before, right? When we created an alert to show the message hello world. In this case, we're going to give a warning to our user. And we're going to ask them, please enter a real value in the text box. All right, so we want to make sure they type something in. And then we don't want any more code to execute, so we're going to type in the word return. So just leave this function. All right, so let's just leave it at that for now. And let's save this. And what I ultimately want to do is I want to replace the value inside of this h1 tag with whatever the user types into the text box. So what we're going to do is add an ID here to this h1. So I'm going to add an ID attribute equals double quotes, and we're going to give it the value of title, so that I can programmatically access this h1's content. All right, and there are a number of different ways to do this. I'm going to take the cheap and easy way out, even though some would probably might point out the fact that inner HTML is not part of any standard prior to HTML5. I'm going to take my chances and go with this anyway, even though because it's implemented in basically every web browser. If that didn't make any sense to you, don't worry about it. Okay. So var my title, creating a new variable called my title, and we're going to save into that the value of document dot get element by ID title. All right. Now in this case, I'm not grabbing the value out. All I really want to do is get a programmatic reference to this h1 with the ID of title, so that I can change it my title dot inner HTML. Again, this is the controversial point, but let's just go with it for now. My value. So we're going to take whatever the value is that the user typed in to the text box, and we're going to substitute that value for whatever value's in the h1. Okay, so let's save this, and now let's see it in action. And we're going to see that it doesn't really work here. All right. So first of all, let's go ahead and click the Click Me button without typing anything in, and nothing happens. And that's our first sign that something's wrong. Let's go ahead and type in some letters here and click the Click Me button, and still nothing happens. Well, what's the problem? Problem is that we have this function, this code that we wrote, but we never really wired it up or hooked it up to our HTML, and that's where this onClick event comes into play. What we want to do is call substitute, open and closing parentheses. So now let's save this, go back to to our Windows Explorer and double click, and now let's click the Click Me button without typing anything in, and we get our little alert box. Please enter a real value in the text box. All right, that gives us a little encouragement that this might actually work. I'm going to type in hello world again, and then click the Click Me button, and notice that the title has changed to hello world again, exactly what we typed in here. All right. Okay, so let's take a short time out here and let's talk about the possibility that something you did caused this application to not work correctly. Perhaps, for example, you misspelled something. For example, let's just say you misspelled the word substitute here as we're trying to call the substitute function from the onClick method, but we use the wrong name and we omit the E on the end of the word substitute. All right, let's save this and see what happens, and nothing happens at all, just as if we hadn't typed anything in. Now, depending on the browser vendor, the browser version, the settings in your browser, you might see a message. In our case, you see no message at all. There's no clue as to what you did incorrectly. So what are you supposed to do then? Well, in this situation, fortunately, Internet Explorer has some built-in tools that can help you get past problems like these. So let's go ahead and go to the Tools menu and click the F12 Developer Tools menu option. You can also get to this by using the F12, the function key on your keyboard. And you can see it opens up this little window in the very bottom of your web page. Now, depending on how you, whether you've used this feature before, you might see it unpinned in a separate window. That can sometimes be helpful as well. I'm going to go ahead and repin this back by clicking the little button underneath the red X, and it now is back and docked into our web page nicely. All right, and I want to go to the script tag, and you can see there's two panes now that we can see with a toolbar. On the left hand side is the script that we wrote, and on the right hand side we see a little message, the console window, and it says refresh the page to see messages that may have occurred before the F12 tools were open. Fair enough. So let's go ahead and refresh our page. And now I'm going to click the Click Me button, and notice that the console window gives me some information, a clue as to what went wrong here. It says substitute is undefined. And you're like, what does that mean? But fortunately, it gives us some additional clues. Like, for example, it has something to do with line number 22. So I'm going to look in the left-hand pane here. I'm going to look at the line numbers here on the left-hand side of my code, looking for line number 22, and it has something to do with character number 1. Well, character number 1 is just an empty space. Well, what this really means, since we're working in the script tab, is the first character of the JavaScript that it encounters on this line. So that would be has something to do with this S in substitute, and we can see here that perhaps we didn't spell something correctly. So we can't really fix it here. The best that we can hope to do is go back to our source code, add the E back in, save the change that we made, open up Internet Explorer again and refresh the page, and try it one more time. And now we get no errors. We notice that the page works correctly, and we're in good shape. All right. So tell you what, let's stop right there. We're going to talk about each line of code in a little bit more depth and give some background information about all this code we wrote and what's really happening behind the scenes, beginning in the next video. And then after that, we're going to rewrite this entire example using a real web development tool, Visual Web Developer Express Edition, and you're going to see the benefits over using just Notepad. So we've got several things that we want to do here in the near future that will build on the concepts that I introduced in this lesson. Hopefully this piques your interest. Keep pushing forward. If it didn't work correctly for you the first time, don't sweat it. You can download the code that I wrote and compare what you wrote versus the code that I wrote. Rewind, pause the video, make sure you typed in everything correctly. And if you get stuck at this point, make sure that you ask questions in the comments below, and I'll try to answer them for you. But if you just stay tuned and you watch the next lessons, I think that many of the questions you may have at this point will be answered for you. Okay? So we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, we wrote a bunch of code. Hopefully it wasn't too complex. Hopefully you were able to figure out what it was going to do even before we ran the example. Hopefully you got it to work just like I did in the video. Hopefully, even if it didn't work originally when you first tried it, you were able to narrow down what the problem was, either by using the F12 developer tools like we demonstrated in the previous lesson, or by simply kind of comparing line by line, looking at what I wrote in my code versus what you wrote in your code. Solving your own problems is a huge part of becoming a software developer, and sometimes you just have to develop that attention to detail to ferret out these little tiny details, a missing character or two that might exist in your code that's causing some problem or bug. And we'll talk about ways to do that and what the possible problems could be much later in this lesson. But nonetheless, in the previous lesson, I really didn't attempt to fully explain everything that you saw me do. Yeah, I made a few passing references to how this is wired up to that and so on, but I didn't really talk about what events were or what functions were or what variables were, so I want to do that right now. And what I want to do in this lesson is explain at a high level what's going on inside of this application that we wrote. Then we're going to spend the next 7 or 8 lessons speaking about each of the individual JavaScript syntax elements and concepts that we introduced in this video and in the previous video. So let's go ahead and get started. So you'll recall in our Hello World example, which you see open right here, that we added in the body tag an onload equals, all right, and we said that this code will fire, this JavaScript will fire whenever the page loads. Furthermore, if you recall in our c9js02.html page, we added this onClick equals to our input type equals submit button form element on our web page. And so I think this is a good place to start. What exactly is going on here with this onload and this onClick attribute? All right. Well, these are These are ways of accessing events that occur on our web page. And events are simply places where we can plug into the web page with our own code. And by plug into, I simply mean that we can write code that executes when those events occur. We plug into those events by telling JavaScript what to do when an event is raised by the web page. So for example, the onload event fires whenever the page finishes loading. So whenever, in this particular example, whenever the HTML is loaded into the web browser's memory, whenever all of the images from across the internet are loaded into memory, which this page references, as well as any external JavaScript files, external CSS files, and any other resources that it might need, at that point, the JavaScript engine will say, all right, we've officially loaded the web page. Is there any code for me to execute whenever the onload event has occurred? In this case, we say, yes, do this. Execute this alert hello world, okay? Similarly, we were able to execute JavaScript in response to a click event. Whenever the user clicks a button on our HTML page, we fired a specific chunk of code that had the name substitute. We'll talk about that in a second. So everything that we do in JavaScript is in response to an event that's raised in the web page, either something that happens during the life cycle of the web page naturally, like the page is loaded, right? Or in response to something that the user has done on the web page, like click a button in this particular case. Now, specifically in the second case, as we're looking at here, we're asking code to be executed by referencing a name of the code, a function with the name substitute. So we obviously wrote this function with the name substitute, so you can see the relationship between the work that we did here and the work that we did here, all right? And the function is simply a block of code that can be called or executed as a single unit. And it's defined as a single unit by wrapping this opening and closing set of curly braces around this block of code and then calling it a function. Now, in this particular case, this function has a name. The name of this function is substitute. And so when the function has a name, we can call it by its name by simply referencing it and then also using these little operators, which in this case, this context means these are the function invocation operators. So execute the function with the name substitute, all right? And so then it will execute this entire block of code together. So we're going to learn more about functions in lesson number 6, but there's a good distinction to cement this idea in your mind, especially if you're coming from an object-oriented programming background like C# or Visual Basic. In VB and C#, you know that classes are the heart of those programming languages. But in JavaScript, things are a little bit different. The function, or rather the function object, is the focus, and understanding the flexibility of the function object and how it differs from other programming languages will ease your learning curve, and again, we'll talk about that more a little bit later. All right, so we started using functions at the very beginning. There are functions that are also built into JavaScript, or more correctly, they're built into the web browser's representation of the web page. This representation of the web page is referred to as the document object model, or rather the DOM, and you'll be hearing about the DOM for the rest of your programming career. In particular, in this example, we use the alert built-in function in order to pop a message box onto the web page, and we did the same thing here in our code as well. We also used another function called document.getElementById, which gave us access to a single HTML element inside of our code. So in this particular case, this whole line of code here that we wrote, we're saying, first of all, get a reference to an element that has the ID myTextBox. So what is returned is an object in the computer's memory that represents this tag called myTextBox, or has the ID of myTextBox, and then we use the dot syntax in order to access a property of that object. The property we're interested in is in the value, whatever was typed into the text box. And then we retrieve that entire value that was typed into the text box and we assign it to a variable. We'll talk about that in just a moment. So we use that dot operator all over the place. You notice that? We use it here, we use it here, we have it use it here as well, here again, and yeah, one more time here. All right. Eventually, we'll talk about all the operators that we use. The single equal sign, like right here for assignment, the double equal sign, and even there's a triple equal sign we'll talk about later on. The opening and closing curly braces, the parentheses we've already looked at. All right. All of these have a purpose and a significance in the JavaScript language, and we're going to talk about those in lessons 4 and 5. All right. So again, the getElementById built-in function gives us a reference to an object in the DOM that represents my text box. Then once we access the text box element, we can grab out its value. In other words, whatever was typed into the text box by the user, and then we save that into a variable. And this is how we define a variable, var myValue. And we assign it immediately to the value that we retrieve. So you use the var keyword to create a function scoped variable. We'll talk about variables at length in the next lesson. For now, or 2 lessons from now. For now, just think of it as a bucket in the computer's memory where you can store your stuff, whatever that stuff is. And you know you'll need to reference that stuff. You'll need access to it later on in your code. So here we're storing the value that the user typed into the text box, and we intend to use that later on in our application here in the very last line of our function, where we're going to take that value and put it into, in this case, the title element. And we'll talk about that in a bit. Next up, we use an if statement to compare the value and to see how long it is or how many characters are in that value. In this case, we're using the dot operator to access a property of this object. This object represents a string value, and we're wanting to say how long is that string. If the string is equal to 0, which means the user hasn't typed anything into the text box, then we're going to execute this block of code as defined by the opening and closing curly braces. And we're going to, in this case, pop up a message and then exit the function by using this return keyword. Okay? So if, for example, somebody typed in the word Bob into the text box, the length would be 3, and 3 is not equal to 0, and so JavaScript's engine would completely ignore this block of code and would not execute it. All right? All right, next up, you can see that I'm using the document.getElementById one more time to reference the element that has the title or has the ID of title. You can see that gets us to this H1, and so now we have a reference to the object in the document object model that represents this H1 tag. Now we can manipulate it with our JavaScript by calling the inner HTML property, or rather using the HTML property to set and change what's in that header with whatever value was typed into the text box from this variable we retrieved at the very beginning of our function. All right, and there is a little bit of controversy around this inner HTML. I want to assure you it is part of HTML5. Previous versions of HTML do not include inner HTML as part of its specification. However, most browser vendors implemented it anyways. All right, so it's pretty safe to use it, but just be aware that it's not a standard if that's important to you. All right, so let's go ahead and make some more general observations now that we've walked through each line of code. All along, I encourage you to make sure that you type the code in correctly, exactly the way that I did it, using the exact use of periods and parentheses and quotations and double quotation marks and spaces and capitalization. As I pointed out before, programming is an exercise in preciseness, so everything matters. Every little character matters. And now the great news is that most web browsers and the JavaScript compiler in those browsers is that they're very forgiving. For example, you might have missed a semicolon at the very end of a line of code, like for example in this line of code. Let me just make that change and hit save, and then let's close this down and refresh our web page. And I'm willing to bet that this will still work even though our code syntactically is not 100% accurate. The fact of the matter is that the JavaScript compiler is very forgiving because there's so much sloppy code out there on the internet. If it wasn't forgiving and didn't try to understand what you were attempting to do, then probably I don't know, 90% of the internet, of the web pages on the internet wouldn't even operate correctly. Okay, so we're thankful for that. However, we need to strive as programmers to write our code correctly so that it offers a consistent experience regardless of which browser that the user is currently browsing with. We can't rely on a forgiving JavaScript compiler because early versions of web browsers may not be as forgiving and a user encounters a problem that you didn't catch during development. So be precise. Be in the practice of being precise. Also, one other note. Each of the elements here, the periods, the parentheses, the quotes, the double quotes, semicolons, the equal signs, they're referred to as operators, and they each have a purpose and a meaning, and without them, the meaning, or if something were to change, if we use a different operator, it could potentially change the meaning of the code dramatically. Also, JavaScript has just a few keywords, words that have important meanings like function and var and if and return and so on. And you can't use, for example, the word var or return as the name of a block of code. You might get unpredictable results if you do that. JavaScript is a small language with relatively few operators and few keywords. The language is powerful because of the ways that these operators and these constructs can be combined to do some remarkably complex things. Unfortunately, that's also one of the sources of complexity in JavaScript beyond the fundamentals that you might run into. All right, so while I was typing the HTML, you may have seen a message about writing JavaScript inside of your HTML. What we did, for example, here and what we did here would be considered by professional JavaScript developers as a big no-no. You should never do this. In Lesson 11, I'm going to right the wrong that I've committed here, but I'm going to continue to take this route because it's the easiest way to include JavaScript inside of your applications. Later on, we're going to focus on doing it the right way. So if you're an expert, you're watching this just for fun, and you're about to write me a note, a nasty note in the comments, I just want to say up front, I acknowledge that what I'm doing here probably isn't the best practice. Please know that I do plan on discussing the separation of HTML purely for content, CSS for appearance, and JavaScript strictly for behavior into separate files. All right, we'll get to that. All right, so after we typed all of this code out into our web page and we attempted to run the application in our browser, the browser first attempted to acquire all the external files like images and external CSS or JavaScript files and then make sense of it all. In order to make sense of it all, it constructs an object model for your web page, like I said a little bit ago, the document object model, or rather the DOM. We'll discuss the DOM in depth in lesson number 13. But while it's constructing the document object model, it'll give JavaScript developers an opportunity to execute code at certain various points in that process. And this is where the load event comes in. And so we can write code that will execute in response to that particular event. The easiest way to write that code, as we did here, is just in the body to add an attribute onload equals. And there are other ways as well. However, the caveat is that the document object model may not yet be completely finished loading. So if we write JavaScript code that references some element in the web page, it may not be available at the point when the onload page has the onload function has executed, or prior to that. So that's quite a pickle, and I'll explain this situation in much more depth in lesson number 15, I believe, when we talk about events. And ultimately, we'll have to keep our JavaScript pretty simple unto then, but there is a very good solution for that as we move to jQuery. So let's move back to our c9jso2.html page. You will recall that in order to demonstrate the use of the F12 developer tools, I wanted to break our web page intentionally by removing the E off of the word substitute, because now it's no longer named exactly the same as our function, right? And so we demonstrated in the F12 tools how it wasn't able to find this function because it doesn't exist by that name. So when you inadvertently introduce an error into your application, depending on the error, the application may not work at all, or it might break at some point during the execution of your program. your user might get a message indicating that the application is broken, or it might be hidden from them. And so modern browsers today typically hide exceptions because there are so many poorly coded JavaScript web pages out on the internet. It would be burdensome as an end user to go to every web page and see